Hey everyone, welcome to the Foundry by Forge College. I am absolutely thrilled to be your guide through this explainer today. So if you've been following along with us, you just wrapped up the Finalize and Present Your Pre-Deployment Checklist and Monitoring Strategy lesson. You've got your artifacts, your alert roles are dialed in, and your checklists are looking pristine. But right now, we are crossing the threshold. We're taking all of that careful preparation, taking a deep breath, and looking at exactly what happens when you deploy an application to the Solana mainnet. Try not to panic, we're gonna get through this together. Okay, let's dive into this with a really serious question. Are you genuinely, truly ready to start spending real SOL? When you're just coding locally, it's so easy to get super comfortable. You write a script, hit enter, it fails, you tweak it, try again, no harm done. But making that jump to production, that means every single transaction, every byte of storage, and every tiny compute operation carries a literal financial weight. It is the exact moment your code stops being a fun theoretical exercise and starts costing actual money. So it's time to find out what testing in production really means for your overall deployment strategy. All right, here is our engineering blueprint for today's explainer. First, welcome to the real world. Second, 3 core network differences. Third, flipping the RP switch. Fourth, measuring network behavior. And fifth, your deployment workflow. Let's jump right in.
Section 1. Welcome to the real world. This is where we move past the pre-deployment checklist.
Think of all your previous work kind of like a flight simulator. You've memorized the controls, you've practiced the emergency procedures over and over, but your feet haven't actually left the ground yet. Well, now you're stepping into the actual cockpit. You are officially leaving that disposable, easily reset devnet sandbox and entering a live production mainnet deployment. This basically means those monitoring rules you painstakingly created in the previous course, they can't just be copy-pasted over. You have to immediately adjust your alert thresholds and completely reset your uptime expectations. Why? Because in a live operational stage, real user traffic is entirely unforgiving. Users out there don't care if a node is syncing. They just know their token swap failed. Compliance matters, real-world latency matters, and suddenly the financial stakes are very, very real.
Section 2, 3 core network differences. Essentially, the sandbox versus the highway.
To put it as simply as possible, DevNet is literally like playing with Monopoly money in a bouncy castle. The state is ephemeral, everything can be reset with a push of a button, and functional testing is completely free. You can crash the car as many times as you want, and the absolute worst consequence is having to go request a few more fake tokens from a faucet. Mainnet, on the other hand, is a high-speed toll road with absolutely zero speed limit. You are dealing with real-value transactions, the on-chain state is permanent, and every single move you make costs real SOL fees. There is no undo button here. If you deploy a flawed smart contract, it's out there in the wild, interacting with actual liquidity and real-life users. Notice how clearly your operational risk is mapped out across these attributes. Now sure, purely functional logic tests are obviously cheapest on DevNet, but look really closely at that fidelity row. DevNet has very, very low liquidity. If your program relies on complex transaction fee microbehaviors, like, say, seeing how your smart contract holds up during intense network congestion, arbitrage bot swarming, or sudden fee spikes, DevNet just is not going to cut it. The environment simply doesn't accurately mirror the sheer chaos of the real world. You need mainnet for that. Additionally, RPC availability makes a huge shift from shared, rate-limited public nodes to requiring paid service-level agreements for any serious application. And suddenly, compliance isn't just a corporate buzzword anymore. KYC and AML checks become a major, completely non-negotiable factor.
All right, moving right along to Section 3, flipping the RPC switch. Let's look at programmatic network selection. So in your actual Solana Web3.js code, swapping environments ultimately boils down to the connection class. By using the clusterApiUrl helper, you define whether your connection is pointing to devnet or mainnet-beta. This one seemingly simple text swap changes absolutely everything about how your client interacts with the blockchain. But don't worry too much just yet. Merely issuing JSON RPC calls for read-only data using these standard public endpoints isn't going to accidentally send live expensive transactions or drain your wallet. You are really just changing the window you're looking through to observe the live state of the network. The mechanics of reading the data are totally safe. It's the writing of data where that massive financial risk actually lies.
And this brilliantly illustrates a really critical operational change you have to make, your commitment levels. On DevNet, you're generally going to use the confirmed commitment level,
It gives you way faster responses because, let's be honest, you just don't require strict finality in a testing sandbox. If a block is rolled back, who cares? It's play money. But on mainnet, no way. You demand the finalized commitment level for your production reads. Why? Because you absolutely need stronger finality to avoid acting on data that might be reverted in a microfork. Just imagine confirming a user's multi-thousand-dollar payment based on a confirmed state, only to have the network drop that block a split second later. In production, you need absolute ironclad certainty before your application responds to a user. Section 4, Measuring Network Behavior, Observing RPC Performance and Slot Metrics.
If you run a really simple read-only script using getVersion and getSlot across both networks, you might output a basic JSON object kind of like this, tracking the block slot and the response duration in milliseconds. Now, tracking this duration isn't just a fun little vanity metric to throw on a dashboard. It is essential, foundational logic for your app. It is exactly how you observe network anomalies, how you spot aggressive rate limits being applied to your IP address, or how you catch critical timeouts long before your actual users ever experience them.
Think about it this way. Say you record a hypothetical 45 millisecond latency baseline over on devnet. You flip the switch to mainnet and boom, it triggers a sudden spike to several seconds, or the connection just drops entirely. Why does that happen? Because public mainnet RPC endpoints aggressively throttle queries to protect the network from spam and heavy traffic. Your application code hasn't changed a single bit, but the actual physics of the environment you are operating in have completely shifted.
So what does this all mean for you? It means you absolutely must actively observe these rate-limiting differences and completely reevaluate those checklist thresholds you made earlier. In fact, in the learning programs and courses we design over at Forge College, we are constantly stressing these exact real-world scaling considerations. You have to aggressively question the reliability of free public endpoints for a live, breathing app. More often than not, observing these choked metrics is the exact aha moment when developers realize, oh wow, I cannot rely on the free tier anymore. This is the moment you realize you need to pull out the wallet and budget for paid, dedicated RPC capacity to ensure your application actually stays online under real load.
Which brings us to Section 5, Your Deployment Workflow, the 4-step decision process.
Here is your operational blueprint before executing a release. Step 1, list the task and the required fidelity. Step 2, map that exact fidelity to the correct environment. Step 3, estimate your real SOL cost and the associated risk. And Step 4, decide on your monitoring and rollback strategy. Let's break that down just a bit. Say you're testing the basic logic of a mathematical function, devnet is perfectly fine for that. But testing live SPL token liquidations that rely on dynamic pricing oracles, yeah, that absolutely belongs on a mainnet staging cluster, definitely not devnet. You need the exact unforgiving physics of the real world to ensure your liquidation engine doesn't accidentally misfire. Now, you might be wondering, what exactly do we mean by fidelity here? Fidelity is simply the degree of exactness with which your testing environment reproduces mainnet liquidity, mempool ordering, and intense fee spikes. Without high fidelity, you aren't just flying blind into a storm, you are doing it without a parachute. Some of the most critical, project-breaking bugs will only ever surface under severe mainnet fee pressure, like when bots are spamming the network and priority fees are just going through the roof. If you haven't tested your app in a high-fidelity environment, trust me, those bugs are going to find you in production. To wrap up your operational readiness, you have to treat the network switch in your code as a highly deliberate, calculated operational step. Use strict environment flags and configuration profiles to prevent silly accidents. Require explicit, mandatory peer review before anyone merges code that points your application to mainnet-beta. This rigorous, careful approach perfectly sets the stage for our very next lesson, which is going to dive deep into the technical weeds of network configuration and Solana RPC nodes, because you are definitely going to need a robust, battle-tested node setup to handle the heavy reality of the mainnet. So, I want to leave you with this final thought. Which test are you going to run on mainnet today, and which one will you keep safely tucked away in the devnet sandbox? Truly understanding these boundaries and respecting the immense financial weight of the network is exactly what separates a good developer from a truly great blockchain engineer. Thank you so much for joining me for this explainer. If you want to dive deeper into this subject, explore a ton of other Web3 topics, and continue leveling up your skills, head on over to forge.college. Keep experimenting, keep building, and I will see you in the next one.